Okay, good morning. So today, actually, can I first get a thumbs up on if you can see my screen and hear me okay? Awesome, thank you. So we're gonna talk about Boolean logic today. And if you were in a check-in group with me yesterday, we talked about this a little bit when we reviewed some code, and I imagine you might have done this if you're with Mike and Meg also. So we want to give more details around how to use Boolean logic, what that is. We want to explain what these words, you probably hear us say truthy and falsy a lot. So what does that mean? How we can utilize these logical operators of and, or, and not. And we'll talk about what those look like. And then we're going to talk about how we can combine these into expressions that might help us condense if statements. And I know my groups, we talked about that a little, so I'm excited to dive into that more today. So we're going to start with the warm-up, and we'll take about 4 minutes to do this warm-up. Oops, I guess I should give it to you before I start the timer. So let me drop it into your channel. All right, so I just dropped it into your backend channel. Try to spend just 1 minute or so, not like, don't go down the deep rabbit hole of exploring truthy and falsy on Google, but I want you to get an idea for that, and then take about 4 minutes to play with the other activities. All right, let's come back together and discuss a little bit. So I've got some follow-up questions. I'm just going to call on a couple people to help me with those. So the first thing, I'm trying to see who I can see here. Robert, if you want to help me out at all, what did you find for what is truthy and falsy? Were you able to find anything on what that means?
Just that it returns kind of true or false, that some values come back as true or false. In Ruby, it's just false and nil that comes back as false.
Okay, awesome. So whenever we type something into Ruby, and I apologize, I should have clarified which Robert. I'm still remembering which names I have two people of, so sorry about that. But yes, thank you. So every expression we have in Ruby will evaluate to, ultimately evaluates to some kind of Boolean, either a true value or a false value, but it's not strictly the true or the false Boolean value. So we call them truthy or falsy. And Robert, you had mentioned the two falsy values in Ruby are, can you repeat those again?
False and nil.
Right, false and nil. So those are the only two falsy values in Ruby. I didn't complete these notes here. So what are truthy and falsy? We have someone else. I really liked your explanation, Robert. I just want to hear from maybe someone else. If you found anything different, or if you want to expand on what Robert said at all, and I'll let someone raise their hand for this one. But just what else did you find about truthy and falsy, or can you restate it in your own words? Taylor, go ahead, thank you.
Yeah, I don't know if I fully understand it, but
yeah.
From what I think I understand, like truthy is anything that's not falsy. So like everything else is either true or truthy if it's not false or nil.
Mm-hmm. Okay, yeah.
Because it's not nothing. I don't know.
Yeah, no, it is a weird concept to play with the first time you hear it. So I think the more we explore it, hopefully the more sense it will make. So thank you so much. Will, go ahead.
I don't know that I have it either, but thought I'd give it a shot.
Yeah.
Is it that Ruby always wants to return either true or false when given the option? And so it like anything but false or nil will be truthy?
Yeah, so it needs because everything has to return something, and any expression we type, and we'll look at some of these variables, or I'm sorry, some of these values that I asked you to play with and pry, because everything's going to needs to evaluate to something, especially if you think about a conditional where I had you use this in an if statement, right? In if, I think when you first learn about an if statement, you might learn or think that this conditional is looking for true. So you might do something like, equals true. But in fact, what this is looking for is a truthy value. So it doesn't even have to evaluate to strictly true, the Boolean true, but it's looking to evaluate to truthy. And that's like this distinction that we want to start to play with. And it's been said a couple times throughout here. So every expression evaluates to either truthy or falsy. And the Ruby makes it very nice for us by only having two values that actually evaluate to falsy. Other languages are going to have different values that might evaluate to falsy. So Ruby's very nice in this regard. So let's actually look at some of these values I had you play with here to see how those evaluate. Robert H., go ahead.
So with this, is this just an arbitrary decision made at the top level of programming when the language was created?
I believe so. So I don't know how they come up with the rules on how they're going to decide what's going to be truthy or falsy. But yes, because different languages have different values that will evaluate to truthy or falsy. So the creators of Ruby decided they're just going to have false and nil. And I don't know the going-ons of what that conversation looks like, but I think that might be an interesting thing to research now that you mention it. Right, okay, so in my prize session here, I just made my variable values to check hello, right? So it's just a string. So if we do if values to check puts I am truthy, and then I do end, right? So the only way, think about our if statement logic, the only way that this block will run inside this branch of logic is if the conditional right here for our if evaluates to truthy. Otherwise, it just won't print anything. So what do you think? Make a guess in your head. Based off of what we said, where Ruby only has two values that evaluate to falsy, will this print I am truthy? And you're just making an assumption in your head right now. And I'll press enter and we'll see if you're right. Awesome. So that did return I am truthy. Thumbs up, thumbs down. Did you get that one okay? Okay, right? This might seem basic, but if we want to understand this at a very foundational level so we can build on it in complexity. All right, let's look at another one. What if we change, oh goodness. Sorry, I messed up my other screen here. Oh, it's okay. If we change, I'm just going to change this to value so I don't have to type as much. So if we change this to nil, if we do if value puts I am truthy, all right, now before I press enter, make another assumption in your head. Will this print I am truthy? I like some people are giving me a thumbs up or thumbs down already. It did not, right? Which makes sense because if this expression evaluates to falsy, it will not go down that branch of logic, okay? What about this? Oh, I guess we don't even need to use variables. I can just put it in like the actual value. What do you think for this one? Will this puts my hello? Ooh, I actually have a couple different responses I'm getting from people. So let's see. It did, it doesn't like my string literal in my condition, that's fine, but it did print my hello, right? That's kind of weird, but an empty string is still an object that evaluates to truthy in Ruby. Okay, is that bizarre? A little bizarre. I think it's weird, but it is what it is. And so what if we did this? Will it print hi? Oh, I like when I see some yeses and some nos. All right, let's check. It did. Why? Why did it print my hi? Does someone want to raise their hand? And oh, Garrett, I saw you first. Maybe.
Yeah, I was actually going to ask another question, but I'm happy to take a stab at this as well.
Yeah, go ahead, guess this, and then you can ask your question.
Because it's falsy. So you say if, so I'm trying to, yeah. And then you want to put hi if, sorry, you put are you evaluating whether your thing is false? I'm actually, yeah. So false is in quotes. So it's a string.
Yeah.
And so you're just putting, so it's still a string, and false in a string doesn't really, it's just still a string, just like any other string.
Right.
So it's going to evaluate to
exactly.
true.
Yep. So false, the Boolean, is different than false, the string. This is just a string. Even though it says false, it's still just a string, which we know strings evaluate to truthy. Okay.
Would you mind if I ask my other question as well?
Yeah, go right ahead, Garrett.
So in one of our previous lessons, when we were going over hashes, we were talking about how like a hash will by default evaluate to nil. So that means like oh, is that not the case? And then we had to set it to equal to by default equal 0.
Let's try it. So right now I stored in my variable value, I put an empty hash. So this is how we can know. This is a really quick way, if you're not sure if something evaluates to truthy or falsy, to check, right? So everyone make a guess. Will this put my hi? And yes, it will. So an empty hash, I'm glad you asked that question, Garrett. An empty hash, an empty array, an empty string, these are all still objects in Ruby that evaluate to truthy. Okay, so even though it's empty, it evaluates to truthy. What you might be thinking of, Garrett, are default values, right? So if I did like value hello right now, that key doesn't exist. And so it returns nil because that value doesn't exist. We haven't set a default value. So I'm not sure if that's what you were thinking of.
Yeah, I think so.
Okay, cool. But I'm really glad you asked that question so that we could show that an empty hash is still a default value. I'm sorry, it's still a truthy value. I'm tripping over my words here. Sydney, do you have a question?
Yes. So you're saying it's returning nil because it's not defined?
Yes, in this situation, my value right here, are you asking about this one, the hash, this what I did right here?
I guess they're all returning nil too. That's why I'm getting
a
little.
Yeah, that's because I'm using a puts. Remember,
Okay.
a puts has a side effect, it prints it out, but then it returns nil. So that's what's going on there.
Okay, sorry. Thank you.
You're good, you're good. Always better to clarify. You were not the only one who had that question. Perfect. All right, go ahead, Jake, and then we'll keep going.
Yeah, so I just kind of ran something in my pry. So I made an array with 2 objects, and then I called if array and then object 2, so essentially a blank one, and puts I'm truthy. It did not return anything because that doesn't exist.
You did like an array with 2 things inside of it?
Right.
Like this?
Yep.
Okay.
And then so I called the if our array in position 2, since that doesn't exist, did not return truthy.
Okay, so right, we can always try this. Hello. And if we put end, so let's think about what would the return value of our array 2 return?
Nil.
It does return nil. Huh, that's interesting then. I would have expected that actually to go down that branch of logic. That's a good question. Let me try something.
It's calling in that array, it's calling the third element of the array, which is nothing.
Correct.
Right.
That's, oh, yeah. I'm sorry. This is working exactly as we expect it to work, right? Because it's only going to go down this branch of logic if this evaluates to truthy, right? But our array 2 returns us nil, so it's not going to go down that branch of logic, so it's not going to hit this block. Right, cool. Thank you for that. I confused myself already. Garrett, go ahead.
Yeah, so I know I just asked a question, but this kind of prompted me to be curious about this. Like, so I believe with hashes, we had talked about a way to make default values equal to 0 if we wanted to.
Mm-hmm.
Is there a similar thing we could do with an array like this, where we could say, if, like, is there a way to make that like any non-existing indexes we try to access equal to 0 and not nil in an array?
I'm going to put that question in our parking lot, which means it's a great question, but it's not in the scope of this lesson, so I don't want it to derail us right now. So I'll put that in the parking lot, okay?
What, as far as the parking lot goes, what's the best course of action to move forward on those after the lesson? Or
yeah, I think we can put that. What I can do, that's a great question. And I don't know that I have an actual answer for that either, but we can definitely put it in our code help channel to discuss those parking lot questions.
Okay, sounds good.
Yeah, awesome. Cool. So why do we care about like these truthies and falsies and these Booleans and these, so what, sorry, I just distracted myself again. So with these, we want to know what truthy and falsy values, because we're going to talk about logical operators. So our logical operators are the and, oh gosh, nope, I want it capital. A lot of times you see it capital to distinguish that it is a logical operator we're talking about. So we have the and, the or, and bless you, and the not. All right. So we don't actually use the keywords and, or, and not in our code. So what is the symbols we use for the and logical operator? I know some of you have used it, but I don't know if you knew what it was called. Does anyone know what the symbols are that we use in our code to represent this? Todd, go ahead.
Ampersand.
Like that?
Double ampersand, double.
Double, yes, exactly. How about Todd, since you're still here, do you know the or?
Yes, it's I forget what you call them, the double straight bars down.
They're called pipes.
Pipes, that's right, pipes.
Yep, double pipes. And then how about the not?
The not, I think you got me on that one.
Okay, phone a friend. Joshua?
Yep.
The bang operator.
Yeah, the bang operator, which is an exclamation point, but it's called the bang operator. So we can look a little bit on how these are working. And these are what we use in our code to do comparisons, to say, if we want to say something like, okay, if this is true and this other thing is true, let's go do a thing, right? Or we might want to say, if this thing is true or another thing is true, go do a thing. Or we might want to say, if this thing is not true, go do a thing, okay? And you're going to see these often in code, whether you end up working in Ruby or JavaScript or any language, you're going to see these logical operators. So it's good to start getting this foundational knowledge now. So let's look a little bit about how these work. We can put them in our pry session. So let's talk first about the and operator. Right, so what this is looking for is, it's going to look something like this. So if we have true and true, so what this is all one expression, and it's going to evaluate to either true or false. So whenever we have these logical operators, they always evaluate to true or false. Okay, So we're going to just discuss the and then we're going to go into breakout rooms to explore the or and the not operators, okay? So, but what this does is this logical operator looks at both sides of the operator to evaluate whether this should return true or false. So now remember, the and is looking for both sides to be true for it to return true as an entire statement. So if both sides are true, I expect this to return true, and it does. Okay, so what if we had this, true and false? Make a guess in your head. When I press enter, what will this statement return now? It returns false. Is that what you thought? Okay, some of you, yes. All right, so remember with this and, it wants both expressions to evaluate to true or false. So what if we did this? What if I did true and hello? What if I press enter right now? Make a guess in your head. What will this return? Hello. Let's do it this way. Right, so remember with our true, our logical, with our if statement, if this evaluates to true or truthy, it will print this statement. So I guess my question is, will it print this statement? And it does. So this logical operator is actually looking for truthy or true values to be returned. Will, go ahead.
In that line 16 there, did it choose return hello because it's false, or it's not?
No, so actually I kind of wish I hadn't have done this. I don't know that I want to talk about like this type of return value because we don't use that too much in Ruby. But it has to do with like both of these are evaluated. So the last thing that's evaluated gets returned. But we don't use that too much in Ruby. Usually we're just using this or operator to evaluate if both things are true, not to get this return value.
Okay.
Mm-hmm. So we're going to be using like in this context where if this thing is true and this thing is true or truthy, then go down this branch of logic. Okay. All right, I'm going to pause here and explain what a truth table is because that's what you're going to be using in your breakout sessions. So, oh, sorry, I should fill out the notes here. So for and, we said, actually, can one of you think to yourself for a second, actually, and then I'll call on one of you to help me share. But if we talk about this and logical operator, so with these two signs, what is this looking for to evaluate to true? What is this looking for in order to evaluate the statement to true? George, do you want to help me with this one?
Sure, I was kind of like confused by that question, but I'm thinking it's looking at both sides individually to evaluate to true.
Yes.
And therefore it is true. It's not either or, it's just, it must be both.
Exactly. So your and logical operator is looking for both sides of the statement to be true for the whole expression to evaluate to true. Perfect. And Jake, do you have a question?
Yeah, so you keep saying both sides. What, like in our battleship, we have one method that has like 4 and statements. Is that okay?
Yeah, definitely. And a little bit later in this lesson, we're going to talk about when you have multiple, what's the order of precedence? So like, how does Ruby know what order to go in?
Okay.
So perfect. We'll get to that. So a truth table is kind of like a X and Y axis table. So like if we had a variable A and a variable B, and they could hold either true or false, then what would be the value of A and B, the value of A or B, and the value of not A? And so for example, what you'll do, let me give you some more room here. You're going to be doing this with your breakout room. So, let's do true. So if A is true and B is true, what are going to be the values of these expressions? If A is true but B is false, what will be the value of these expressions? If this is false and this is true, what will be the value? And then again, so we are looking at all possible combinations. And then your job as your group, and you can have one person show this on the screen, and you can all be writing it. This is easier to write, but obviously we're virtual here. So you with your group will fill in the values of these expressions. Okay, any questions about what you're going to be doing? Cool. Right, let me get you into some breakout rooms. And then when we come back, we'll take a palm. Why is this not? Sorry, one second. Okay. All right, your breakout rooms are open. I did account for people who should not go into breakout rooms unless they want to. Actually, I didn't make it, they could. Quick, for some of you got it really, really fast. And what you were just evaluating all these expressions, right? So did any questions come up, any gray areas come up, anything surprising, anything like that? Sydney?
So I just want to make sure I'm understanding. So the way that we set this up, we're saying, like, for example, the first one, we're saying A is already evaluating to true, B is already evaluating to true. So like A equals true, B equals true.
Mm-hmm.
Okay, I just wanted to make sure, then that makes sense. Because I was like,
okay,
we were getting confused, like, do we want them to match? Like they're the same on both sides, like for that double and, but then it was like, no, they're already, if they're variables, that makes sense.
Yeah, okay, perfect.
Okay.
Yeah, and I think sometimes these tables like take a minute to get used to. So I wanted to give you this one because we'll do a slightly more complicated one in a little bit. So like, for example, what did y'all put for this one? When A is false and B is true, what is going to be the expression of A and B? We just say A and B.
False.
Why?
Because they would both have to be true.
Right, exactly. So thank you, Sydney, for hanging out with me here. So yeah, remember the and operator is looking for both sides to evaluate to true, for that expression to evaluate to true. And we're just going to stick with true and false values for today. And then how about Jose? Can you help me with this one? If A is false and B is true, what's going to be the value here of my OR operator, A or B?
True.
True. Yes. Why?
Because as long as one is true, that's all that needs to pass.
Yes. So this one, our OR operator is looking just for at least one side to be true for it to evaluate to true for the whole expression. Awesome. Thank you so much. And then the last one, how about Nick? If A is false, if we use that Bing operator, what will this evaluate to?
It would be true.
Right. And then, so what does the Bing operator do?
So the Bing operator would be like the opposite of the truthiness of whatever's after it.
Yeah. So it like flips the Boolean value, right? So if it started off as false, you stick a Bing operator in front of it, the variable, and it's going to flip the Boolean value, so it'll be true. So maybe these were slightly trivial examples, but the idea is we're going to build on this, but the logic will remain the same. Okay, so let's take 5 and then come back. So at 9:45, we will start again.
Thank you, 45.
Love it. Creepy. Just kidding. Oh, that was recorded. Okay, so now we're going to go back to the question about precedence. So let's consider for a second what would happen, if you can see my price session here, if we had this statement. We had false and false or true. So just take a second and make an assumption. When I press enter, what do you think this expression is going to evaluate to? Okay, everyone have a guess in their head? I mean, you got a 50-50 chance, right? But try to make an educated guess just based off of what you think is happening here. Okay. All right, is that what you thought? Maybe? Okay, you said yes. So how about this one? And we'll talk about this. True. Oh, not a 7. There we go. All right, make a guess in your head with this one. Okay, everyone have a guess? Cool. Oh, I saw some people say, no, that's not what I guessed. Okay. So if you're like me, when I first learned about this, I thought always left to right, right? But it's not the case. So for evaluating these kind of comparisons, these operators, we have a precedence table. Actually, I'll put this in your channel, right? So that you all have it. So I just dropped it in your Slack channel. Now, Ruby will evaluate an expression on order of precedence, starting from the top of this table and then going down. Okay, so you'll see all these other operators in here as well. You have our greater than, equal to, our comparison operator here, and then these operations are way down at the bottom. Okay, so this is the order Ruby will evaluate this in. So based off this table, let's make another guess. Let me move this over. So based off of this table and this expression, take a minute. If you need to write this in a notebook, I always have to write it down. See if you can figure out what this will evaluate to. We'll give you about 10 seconds. Okay, I think that was 10 seconds. Everyone have a guess? Okay, all right, let's see. I see some cheering and some not cheering. So let's talk about how Ruby evaluated this. So, all right. Actually, I don't want to talk about this. How about one of you can explain what happened here and kind of walk us through the logic? Yeah, Garrett, go for it.
I don't know. I'm probably gonna be totally off. So the way I thought about it was, given the order of operations, it was evaluating the middle first. So it'd be like true and false, and it evaluates that. And then like in my head, the way I thought about it was like, okay, true and false. So that middle can now just be basically just a false. Yeah. So now I looked at it like false, pipes, false, pipes, fight, false. And then like they're all false, so it's just equivalent to false. Exactly. I think that was a great way to think about it. So thinking about what is Ruby going to evaluate first? So we can see from our precedence table that the logical and gets evaluated before the logical or. So this
will first evaluate to false, so we can then rewrite this. This reminds me of like math problems, how you're like condensing everything until you get your solution. So it evaluates to false, and now we just have pipes. So when all the logical operators are the same or on the same level of precedence, then Ruby just goes left to right. Okay, so if same level of precedence, okay, that's a capital. It's a very important word. Then Ruby evaluates left to right. Okay. All right, let's do another practice for you real quick. So what if you had this one? False and false or true. Okay, so make a guess in your head for this one. Okay, have your guess? Oops. Yeah? Okay. What if we, oh gosh, nope. What if we did this? Now what's going to happen? Let's try it out. Still false. Okay, wait, I didn't like that example. What if we did this? I was hoping it would do a different one. These are hard to, this one. Oh no. Having a hard time here, friends. There we go. So when we add in our parentheses, it changes the order of precedence, right? The parentheses, whatever's inside our parentheses will evaluate first, and then it will continue along this precedence table, okay? So another note here is adding parentheses will cause Ruby to evaluate. I'm wording this terribly. Let's do this. Parentheses will evaluate first. Okay, Joshua, go ahead.
Can you review some of those other
Yes,
operators?
Yeah, thank you for asking that. I'm just plowing right through them, aren't I? So let's, review these operators.
Yeah, no. So like,
and I'm saying no because I think we could have a whole class on like what this spaceship operator does, or like what these tildes do. So I think if you're, and this triple equal, some of these you're not going to use very often, but it's good to know where they are. So that's definitely something I would encourage you to like Google and do some research on. But unfortunately, we just don't have time to explore those right now.
Okay.
Sorry, I thought you meant these. So but I should ask that question. Does anyone want me to review any of these that we went through? Aiden, go ahead.
I'm just pointing out that I don't think any of the conditionals that like 1 through 4 indicate that Ruby doesn't operate on left to right. Because if you only look at them left to right, they all come out as what they come out that add in pry.
Okay, so you want to explore more is what you're saying.
Like if
I see what you're saying. So my examples do not fully illustrate the power of the precedence, and they're all appearing to go left to right. I totally get what you're saying. So let's do this. Let's do some breakout rooms and really explore this precedence, or how Ruby goes through the precedence and the order of operations. Okay, because I think that will really help. So we're going to. I'm going to put this in your breakout room. You're going to use a truth table again, but now instead of just A and B, you're going to have A, B, and C. And I'm going to link you a spreadsheet that I hope you all can see to use as a guide. So I just dropped that in your Slack channel. See, give me a thumbs up or thumbs down if you can open that Google spreadsheet, okay? Okay, I had a thumbs up. I would like to see at least one more thumbs up if you're able to open that spreadsheet. Okay, awesome. So that's what you're going to work on with your groups, and to really evaluate what's going on. Okay, it'll get a little brain bendy, but it'll be fun. All right, let me get you into some breakout rooms. Aiden, I agree. Thank you for pointing that out, though. Okay. Okay, let me make sure everyone's in a room that they can work in. All right, so I would have one person kind of take over the screen, and then you can all work together to discuss and fill out that truth table, okay? All right, and we'll do that. We'll probably work for about 10 minutes or so. All right, rooms are open. All right, oops, that's not what I want to show. What questions did you have? And then maybe I'll ask one or two of you to show your solution. Any questions come up? Anything that like really threw you for a loop or was unclear or anything like that? Oh, I don't have my thing open. Okay, so I think it can get super complicated, right? And then you just have to take your time and pull it apart. I would say usually in code, you're not seeing like super nested structures like that last one you had to do. If someone turned in code to me and they were evaluating something like that, I would probably ask them to clean that up a little bit, because then, you know, how many devs are going to have to come and look at this and say, like, really take the time to evaluate what the heck was happening here. So how about, do I have anyone who wants to like spotlight and like work through this one? If we did A is true and we did B is false and C is true, Kate wants to take it on. Okay, Kate, what's the best way for us to do this? Do you want to just talk me through what you're doing?
Yeah, I will talk you through exactly what my group did.
Perfect.
So from left to right, just starting that way, because there are a lot of parentheses going on here.
Yeah.
So we take the big parentheses on the left, and so like that big old thing, so the whole big thing before the or. And then once looking at that, we take the first parentheses set. So we evaluate A and B, so true and false.
Okay.
So that's going to be false. So
Cool.
we know that that's false.
Let's just put that in there then.
Yep.
Okay.
And then we take the bigger thing of false and not true. Not true is false. So you have false and false, which is false.
Okay.
And a little shortcut here, if this had come out true, I would have stopped.
Yes. Why?
Because if you have blank or blank, and one of them is true, it's going to evaluate to true.
Yes, and you'll hear this term called short-circuiting the code, and this is what you're doing, because if this is true, you're going to stop it, kind of short circuit, and it's not even going to look at what this right-hand side is.
Yes,
okay? Awesome.
But this evaluated to false, so we have to keep going.
Figures.
So same thing on the right side. We're going to look at the whole big thing, but we're going to start with the little set of parentheses. So we have true and true, which is going to evaluate to true, and not false, which is going to evaluate, and not false, which is going to evaluate to true. So we have true and true, which is going to be true. So we have false or true, so this evaluates to true.
Awesome. Yay, great job. Thank you for doing that with me. Cool. Yep. Any questions come up? Okay. So why are we talking about this? How is this going to help us with your actual code, right? Let's consider this real quick. So normally you don't have like A, B's, and C's all over the place, or do you, right? Because those are just variables. So yes, you probably do, but you might have called them like is sunk, Or maybe this variable is called, help me out here. What are some other like attributes that this might be? Like, is hit, is that one of them you might have? Something like that, right? Or maybe you don't have that, the is. You could just do hit, sunk, something like that, right? Empty, right? So you kind of do have these variables. And what's super cool, I talked about this yesterday in Ruby, is, you know, with these question marks, you know your method is going to be returning a Boolean, a true or a false. So then you can utilize the return value of these methods to work through some conditional logic like we were doing up here. And we can use these logical statements to condense nested if statements. So for example, in this playground here, I have this little tiny method analyzing some kind of animal. And so there's, if the animal is a cat, so if that evaluates to true, it's going to put, I am a cat. But then it's going to look a step further and say, okay, well, if you have fur, then add this statement, a cat with fur. Needs a space. Else add without fur. Otherwise, from here, from this first if statement, you can do, I am not a cat, right? But we can condense this because we know if it's a cat and if it has fur, we want it to say, I am a cat with fur. So what I would rather see here is, what if we did this? If you have a cat and the animal has fur, then we can just move this into here and say, I am a cat with fur. And then we could do an else if here. Oh gosh, oh gosh. Else if we could do animal.cat. Actually, we could just leave it that. Then you could do, I am a cat without fur. Else, I'm not a cat. Okay, so we can use, sometimes it takes a minute to think about how we can condense a nested if statement. But if we think about what are the logical, like what is the flow? And now I kind of wish I had okay, I do, the old one. Right, if we look here, how would we get to this statement here? Well, if we think about our logic and how this is going, we needed a true statement for animal cat and a true statement for animal fur. If both of those are true, it's going to print this statement here. So instead of breaking that up into a nested if statement, we can just add that into a logical statement and then condense it so that we only have one level of this if statement. Nested if statements are actually extremely expensive in terms of computing power. So if you can avoid those, I highly recommend it. Plus, it gets pretty difficult to read, especially if you have like a double nested if and a triple nested if. It's really difficult to follow all that logic. Okay. Or if I can't talk. Or this one, how would it get to this branch of logic? Animal cat would need to be true, but then animal fur would need to be false. So you could actually do and not animal fur. It would depend on if there's other conditions it's looking at. In this case we have here, it's not looking at anything else. So if it didn't pass this one, then it would have to be this one. So this is a little redundant. But if you're not sure at first, you can always add it in. Otherwise, not a cat. Any questions about this? So I'm going to have you do a little bit of practice with it. I'm changing the activity a little bit because of time. Okay, so what you're going to do is going to take you the rest of the time, and then we'll come back together just for a really quick recap. All right, so there is a GitHub repo for you to clone, and either one of you or all of you can clone it. You may to install, step 4, you might need to install a couple gems to get this working. So you wanna make sure the test is working first. If it's not, install those 2 gems. But what you're going to do is try to refactor the code kind of like in this fashion. So usually if you add like, if you have a string that's broken up, like I am a cat with fur, without fur, like this is fine. This actually cuts down some repetition of the I am a cat, but I'd rather see a little bit of string repetition than a nested if statement. So you're gonna work with your group to see if you can condense the code a little bit. So I would really suggest picking one person to screen share, and then you can all kind of walk through it. Are there any questions to what you're gonna be doing? All right, let's get to it. I'll hop around the rooms because I think there will be questions as soon as you open it up. Okay, I know that was rushed, but I know some of the groups were able to get some refactor done, but because we're out of time, well, it wasn't my intention to review that anyways, but I highly recommend you review it with other people, like in your cohort. You can put it in the backend code help to see what other people did to refactor and how they used their logic to condense those if statements. And so the challenge becomes, how do you apply that to your projects now? So I just want to review super fast what we talked about the order. We talked about our logical operators of and, or, and not, and how those work. And we talked about our precedence table, so that we know Ruby always is going to evaluate these in the order of this operation. So if you get some behavior you're not expecting, maybe the order of precedence is incorrect in your code. And then of course, adding parentheses, it'll evaluate inside that parentheses first. Okay, cool. So I know this ending was a little bit rushed. Please take a break until 10:40 and then go back into Emma is going to do your